there has been such a breakthrough in autoimmunity. It seems like nobody's talking about it except for me. I have 2 books on it. Okay, this is what's going on. There are 3 attack modes. There are 2 checkpoints in the body to check that. And there's this one mechanism or cause that creates these divergent expressions that is every autoimmune condition. Okay, so you've probably been told autoimmune is the body attacking itself. The question is, why? Why is this happening? So I put this together and I made this sort of poster from my office to help explain to my patients when I'm going through this. And there are 3 different attack modes. Number 1 is a direct attack. It's to the T cells that are attacking your normal healthy tissue. That's attack mode 1. Attack mode 2 is within the germinal center of the lymph node, the B cells make antibodies. And they can make a flawed antibody. And that antibody will go out and attach onto a healthy tissue that signals the macrophages, neutrophils, and the natural killer cells to come in and attack that and take that out, to destroy that cell. And then third is molecular mimicry. And that's when a pathogen, such as Epstein-Barr virus, there's many, and we'll go through this. It has the same surface proteins as our healthy tissue. So an antibody that's made perfect for that surface proteins of those antigens, that pathogen, will match our tissue itself. So you have 3 different modes that you can create this. But the body has 2 different checkpoints. It has checkpoint 1 that's actually in the germinal center of the lymph node. And what it does is the B cells, which are making these antibodies, it's like this super production line that's making all these different prototypes to see which antibody is going to fit the key for that antigen. And to make sure that the bad ones, the ones that aren't exact, don't go out, you have a cell called a TFR cell. It's a T follicular regulatory cell. And those cells are inside the germinal center, and they're the auditors. They look and see if that is perfectly made for that antigen. And if it's not, it basically allows that to be destroyed or killed. So only the good, perfect, or near perfect antibodies are allowed to be released after the B cell factory is making that. So that's checkpoint 1, just to make sure that the antibodies are perfect, okay? And so you can see that would affect mode 2, where the body's putting out bad antibodies. In other words, if you don't have these TFR cells that are functioning optimally, if you don't have enough of those, you can put out some poor antibodies, some flawed antibodies. And then you have checkpoint 2. And this gets really interesting. That's where a T cell can become what's called a Treg, or a regulatory T cell. And their job is to patrol the tissue, and they have a domain over the T cell. So when a T cell goes to attack them, they stand between the T cell and the healthy tissue and say, no, this is healthy tissue, stand down. They also tell the T cells to stand down after the attack is over. So in other words, they've won the battle, they've come in contact with a pathogen, they destroy that, and they say, okay, your job's done now. You don't want to keep going and start then attacking healthy tissue. So those are the 2 checkpoints. And it's really interesting because both of those are controlled by one gene, and it's called FOXP3. That gene is so vital that it won the Nobel Prize for Physiology or Medicine in October of 2025. It's one of the biggest discoveries probably ever. We can probably put it in the top 5 to 10 discoveries behind things like Nobel Prize wins, penicillin, antibiotic, which is the penicillin, insulin, DNA, discovery of DNA, and you have FOXP3 and Tregs, and and self-tolerance. Okay, so you have in different autoimmune are going to be different, like a celiac disease, type 1 diabetes. They're mainly going to be attack mode 1. T cells just attacking, for instance, the pancreatic cells in type 1 diabetes. Okay, in lupus, that would be more attack mode 2. Flawed antibodies are going out and affecting different tissue. And then you have molecular mimicry. That would be like ankylosing spondylitis. You have both Proteus mirabilis and Klebsiella, or both have molecular mimicry. In other words, the perfect antibody that matches that also matches some tissues within the joints. Okay, so if there's one cause, that's FOXP3 gene, because FOXP3 controls both the Tregs and the TFR cells in the germinal center of the lymph node. So this is huge, and no one's talking about it. Now, here's where it gets really interesting, because FOXP3 is what one of the Nobel laureates, Mary Bronco, said it is a non-druggable target. It sits on the X chromosome within the nucleus. Okay, so it can't be, the drugs can't reach it. What does affect it? Metabolic pathways. So there's different, and how do you affect these metabolic pathways? Through nutrition and lifestyle modification. So we've created the FOXP3 Protocol, which is designed to help stabilize and optimize FOXP3 so that you have optimal Tregs, the regulatory T cells, and the T follicular regulatory cells. Okay, so this is the two main ways, the two main checkpoints you can stabilize. And by the way, that stabilization, they become unstable usually in different lifetime events. Either you had a bad infection, you may have had a severe emotional trauma, like a person died, a loved one died. You can have perimenopause, or it was like after the birth of a child. And so you'll see so many of these autoimmune conditions occur right during those period of times when it's a bit unstable. It's been unstable from different environmental factors, and then something occurs and boom, that it takes out FOXP3, and you have a dysregulated FOXP3 system. The thing is, we can bring FOXP3 back. That's the great news. So if you're suffering, if you have an autoimmune condition, understand this isn't fringe science of any kind. It won the Nobel Prize. They give it to, and it not only didn't win the Nobel Prize, it's considered to be one of the biggest breakthroughs. So this is huge for you. And the great thing is, no matter what else you're doing, you can still use diet and lifestyle to stabilize FOXP3, to allow your body to function the way that it's supposed to function. Your body was created with this amazing intelligence. It knows how to run the body. It does it through FOXP3 is the immune regulatory system. Your body will always be better with a well-running immune regulatory system with a stable FOXP3 than a chaotic, dysregulated FOXP3. So let's get that stabilized. Go to drraywellness.com and we'll help you out.